Hello, my name is Ethan Lee, and today I'm going to be doing a short introduction to competitive programming. This is the first part because competitive programming is a big deal and there's two parts to this. Okay, so it might not make sense when I'm saying what competitive programming is. So, what is competitive programming? In simplicity, it's basically just programming, but you get prizes for it. Essentially, you're given problem statements and you need to code up specific solutions that can pass test cases. If none of those words make any sense, don't worry, I'll go over them. This is actually very different from hackathons. Competitive programming has a specific skill set that's different from what you normally do at a hackathon. If you're interested, competitive programming is often hosted on sites like USACO, the United States of America's Computing Olympiad, and Codeforces, or sometimes abbreviated as CF. So basically, this is the general idea of what competitive programming is. But what exactly would a problem look like? Let's take a look. Now, this is an example of a competitive programming problem that you would find on Codeforces. I'm just going to give a few seconds so you can pause the problem and look at what's going on because there's a lot. Okay, hopefully you paused the video. So let's take a look at what's on screen right now. So first, you might notice that there's basically three sections to this problem besides the title and obviously. There might be an input and an output that's specified. So in this problem specifically, it just says that it's standard input and standard output. But besides that, there are three main sections to the problem. There's a problem statement, input-output format, and a sample input and output, sometimes with a input and output explanation. So first, let's take a look at the problem statement. Basically, what this is just what the problem is. It describes the situation that you need to look at and you need to solve. So in this case, for example, the problem statement basically reads A plus B. Can you solve A plus B? So after reading the problem statement, you'll understand that you need to write a program that, given some input, will be able to print to output A plus B, basically. So what do I mean when I say input and output? That's where you look at the next two sections. The input and output format describes how you will receive the two numbers that you need to solve A plus B. So if you read here, the input contains two integers A and B separated by a single space. And you'll see down below that that's basically how you're going to be getting your input. And your output basically specifies what you need to print in order to solve the problem. So output the sum of the given integers. And finally, if you take a look at the sample input and output below, you see 5 and 14, and then the output 19. So the sample input and output basically helps you visualize what exactly the input and output looks like and what you need to do. Okay, so you see the input that you're getting from the standard input, and you know what you need to output to standard output. But then how exactly do you actually go about doing that? Well, there's a few core parts to every competitive programming solution, if you will, that I'll be going over right now. So the three parts to solving a competitive programming problem are to read in numbers and data from standard input. You do the problem, and then you output to standard output. In this case, you read in the two numbers from the standard input as specified in the sample input. You add them, and then you output to the standard output as specified in the problem. So you read 514 and you print 19. So let's take a look at a sample Java code that would go and solve this problem. First of all, you notice that it's color-coded. There is a red section, a green section, and a blue section that corresponds to reading in, doing math, and printing out. So let's take a look. You read input by using the scanner class, which we've described in previous videos, and you use that and read from the system.in and take the two numbers that you need. Then you add them using, well, the code that's in green. And finally, you print using system.out.println, and then you can print to system.out and you have your answer. This is an example of code that would work, that would be able to solve the problem when put to code forces. Okay, so to recap, every competitive programming problem consists of a problem statement, an input and output format, and a sample input and sample output to help you understand. And every solution consists of 3 parts as well. You read in the input, you do the math the problem statement tells you to, and then you print the answer. So, sounds simple, right? It gets way harder, trust me. Now, before I go any further, let me talk a little bit about why you want to do CP at all, or competitive programming. So there's a few bullet points on the screen right now that you can take a look at. First, you get to learn data structures and algorithms that are useful outside of competitive programming. So for example, you come into contact with sets, maps, lists, stacks, and then later, for example, more complicated structures like graphs and segment trees. So basically, you can use these data structures and algorithms and practice them while doing competitive programming, and they'll still be useful outside of competitive programming when you do other computer science related things. Secondly, you gain a very deep understanding of a coding language. This is pretty self-explanatory. You code in a language while doing competitive programming, and after a long time, you get all of the knowledge that you really need to. Third, you can make friends who are very driven or ambitious or insufferable. And you can also become driven or ambitious or insufferable. Competitive programming is a gigantic time sink, I would know. Basically, it takes about 2 years just to get from no experience to one of the best. And it really takes a lot of dedication. So if you really spend a lot of time with competitive programming, you can build that skill, as well as spending time with other people who are very, very dedicated, if that makes any sense. Also, you can win awards and put things on your college resume because it shows dedication towards computer science. And then finally, and I know this sounds cheesy, you can train your mind. I'm not kidding. When I started competitive programming, I thought about problems in a very different way than I do now. I'm not really going to go into that. Okay. And finally, let's take a look at a few resources that you can take a look at if you want to look more into competitive programming. First, there's USACO, which is arguably the biggest high school level programming competition in the nation. You see the website there, usaco.org, and there's a lot of extra resources compiled by former USACO big names and winners at usaco.guide. Next, there's Codeforces, which is essentially a community-run CP hub. I talked about these in previous slides. You can take a look at codeforces.com. There's also, obviously, your CS teacher, who knows a lot about algorithms and data structures because, they're your CS teacher. There's also locally based CS clubs, depending on where you are. There's probably some like CS club or organization that you can take a look at and learn from. And finally, all of your nerdy friends, because chances are they know a lot about coding already. So when you start competitive programming, or if you start competitive programming, always remember that you're not alone and that there's a lot of resources out there that you can seek help from. Okay, so that's the end of part 1 of the competitive programming tutorial. Next time, I'll talk a little bit about some of the algorithms and data structures you might need just to dip your feet in the water. Thank you.